Hi, everyone. Thanks for coming to my talk today, and thank you for the organizers. Today I'm going to discuss some work we did this spring in partnership with the Nobel Prize Outreach organization here in Stockholm to enhance an existing knowledge graph with some keywords extracted by an LLM. So let's get to it. So I think we're all probably fairly familiar with the Nobel Prize organization. They've awarded over 1,000 Nobel Prizes to recipients in various fields. And they do a lot of work to not only provide these prizes, but also do education work. So do programming to educate the public on how these things work, who these people are, what their contributions have been. And this can be either public-facing outreach programs, but also the museum. And so the museums. And this particular project was to try to expand some data they already had, in order to better explore the information they had about their laureates. So we partnered with them at EQT and the Motherbrain team. EQT is a private equity firm here in Stockholm, and the Motherbrain team is a data and AI team within EQT. We were also working on knowledge graphs at the time. So in private equity, when we think about knowledge graphs, we think about companies, industries, geographies, people. We think about relationships in terms of what industry does this company belong in, what industry does it operate in, what company is a customer to another company, etc. And we also have this concept of keywords. So what products does this company sell? What are their services? What is the business model? Is it business to business, business to consumer, whatever? On the Nobel Prize side, they have a very similar graph. It's heterogeneous. It has multiple nodes, multiple edges, nodes and edge types. Their nodes are the prizes themselves, chemistry, physics, mathematics, economics, not to mention the years that these prizes are rewarded, the laureates themselves, where they worked, where they lived. The relationships are who was awarded what, who worked where, who was born where, living in, and then the keywords also is what we want to focus on today, is the fields of impact. Like what field was Albert Einstein working in when he made his discoveries? What field is the prize most focused on among or within that laureate's work? So the main question I think we're going to focus on today is how to enrich an existing knowledge graph with more keywords, to kind of fill out this connective tissue to meaningfully connect entities that we might be interested in. So what we did, I'll walk you through. It had kind of 5 steps. One was to assemble and assess the original knowledge graph. And then one was to take a bunch of extant documents that we had about the laureates. We have their speeches, we have press releases, we have Wikipedia articles, and extracting relevant fields of impact from those documents. Identifying and merging those fields. So if we found, and I'll get into this a little bit later, but reducing the number of fields that we had that were maybe overlapping or duplicates or redundant. Enriching the original knowledge graph that we had with those, and then doing some internal investigation or internal evaluation within the Nobel Prize Outreach organization to make sure that these things were high quality. So the original knowledge graph that we assembled we started with Wikidata. If anyone hasn't used Wikidata in the past, we highly recommend it. It's incredible. It's relatively easy to access this data, and there is a ton of it. So we assessed this as kind of the backbone for the knowledge graph we wanted to build. And it had, surprise, information, at least some information for all the Nobel Prizes and the laureates. It had, for example, their university affiliations, where they worked, what lab, etc., and other awards. However, it didn't always have their fields of work. So maybe it didn't always know that Einstein worked in physics or Hinton worked in machine learning. And we found that in the cases when it did, they tend to be very generic and not specific enough. So we can see maybe this person worked in history or in mathematics, and that wasn't good enough for us. Should have mentioned the goal that we had for this knowledge graph is to find a subset of keywords that linked a few, but not too many, laureates together so that we can start to draw parallels between different people in different fields of work. And I think one of the ultimate goals we had in mind was to develop some kind of interactive tool. Imagine a giant touchscreen at a museum that you can drag and drop and zoom in and float around and dive into, that is a graph of the laureates and their work. So that was the kind of the main goal, and that goal and that kind of connectivity is something that really was central to our evaluation of this, which I can describe in a little bit. So the first step was keyword extraction. As I said, we have as our input, we had the laureates, we had their biographies, the lecture they may have given during their acceptance, and the Wikipedia. And then on the prize side, the Nobel Prize organization puts out press releases and a speech, an introductory speech about this laureate that is also recorded and documented before they receive their prize. And then for the method, we tried a couple different things, but the method we settled on was giving a document to an LLM and say, please extract the keywords, just ask for keywords given this text. We had to kind of iterate a few times on what keywords meant, like extracting keywords, because we found that asking it to extract keywords without much other further detail got us a lot of stuff, including maybe their hobbies. These people like to go mountaineering. These people love to cook, whatever. But we were really focused on what their fields of impact were, and not other like kind of occupations or hobbies or whatever. So we ended up landing on, in addition to the document and the task, the input document and the task, we mentioned like, please extract terms from specific taxonomies. And we had 7 of these. And these are kind of taxonomies that contain kind of well-known, recognized, scientific, economic, and professional words, right? And the interesting thing that we found was we didn't need to enumerate all of the terms found in medical subject headings or physics subject headings. All we had to do was mention these taxonomies to the LLM, and it kind of took care of the rest. We were fairly impressed with that result. So after we did the first round of extraction, here is a histogram of the number of laureates attached to each keyword. And so you can see we have a fairly long tail, but we also have on the very left, we had about 2,900 keywords that were only attached to a single laureate. And that didn't feel right because, again, we wanted to make an interactive graph that could connect and bridge between different laureates. So we wanted to find a sweet spot where we would have maybe between 3 and 10 laureates per keyword. So we had to do something to kind of fix this situation. And what we ended up settling, as we inspected this, we found out that there was lots of keywords that were extracted that were actually basically synonyms of each other. So we developed a kind of a hacky system to deduplicate these synonyms. What we did was we used the OpenAI's Added2 model to take document embeddings for all of these keywords that we extracted, and we took the cosine similarity between each pair. So we started with 5,000 keywords, and pairwise cosine similarity gets us to 25 million keywords. Then we did some visual inspection and gave ourselves a threshold cutoff for similarity. So we said we're only going to further process keyword pairs that have a similarity score of 0.7 and above. This is just based on looking at them and doing some Google searching, Wikipedia surfing. What is click chemistry? What is bioorthogonal chemistry? Are these similar or not? Yeah. So once we have these kind of synonym candidates, what we did was we passed each pair to an LLM and said, here are 2 keywords. Are they the same? And if they're the same, please just merge them, choose a new keyword for us that represents both of these. And if they're not similar enough, maybe they're similar enough in terms of cosine distance, but not similar enough in terms of semantic meaning. Don't do anything. Let's leave them alone. Let's return an NA. So you can see in this screenshot, X-ray technology and X-ray technology, which obviously are basically the same, both get merged into X-ray technology. But on the bottom, we see that click chemistry and bioorthogonal chemistry are apparently not close enough to be merged, so the model returns an NA. We ended up to save a bit of computation, we just took the new to develop a new embedding for this so we could repeat this process. We just took the average of the original embeddings. Yeah, and so you can see this little sweet spot, this little dotted orange line is what we're kind of hoping for. So this histogram is the initial kind of distribution we saw, and then as we iterated once, we can see that the distribution gets pushed to the right. We have a bit more occurrences in the 3 to 10 range that we're looking for, and then we decided to do it a third time, and you can see that now we have like even more. Let me just kind of do a manual GIF and flip back and forth. Now we have this kind of like a higher population of keywords that are kind of filling out this sweet spot. We were pretty pleased with this, and we stopped after 2 iterations. There was no more reason, no analytical reason besides the vibes were good to stop after 2 for this. We constructed a graph after this. So we loaded all this data, the wiki data and the merged synonyms into Neo4j. Here you can see an example of this. We have the blue line is the blue node is a year was rewarded. We see that these yellow nodes are the laureates, and the purple nodes are the keywords. To go really fast, I'm about to run out of time, so really fast to the AI versus expert curated keywords, we saw they were really good, but compared with the keywords that the Nobel Prize experts are describing themselves, they tended to be less specific. And we found that was okay, actually, because we found the expert keywords on their own were maybe too specific and maybe kind of living too close to this 1 per laureate zone that we didn't think was appropriate to build an interactive graph with. We also saw that the prompt that we used to extract these keywords maybe wasn't smart enough to retrieve enough context. So the experts that we reviewed these keywords with said, well, this person didn't work in this field. She actually was vehemently opposed to this field, or this expert didn't work in this field, but his work gave rise to this field. So this felt like a bit of a distinction that was really important for kind of different use cases for these keywords. Maybe if you're trying to be very, very precise, write a biography about these laureates, but we actually felt that this was a positive in terms of building a knowledge graph, especially an interactive one where you can say, well, this person was somehow related to this field, and let the user kind of learn a bit more about it. And I think honestly, this could easily be improved on in a second iteration of this if we were to pursue it, where we, in addition to the keyword, ask specifically for, well, what was the relationship to this field that they worked in. The clear advantages, the advantages were clear though. We got way more scale. We're able to develop more keywords, process more documents, and really enhance this knowledge graph. So everyone was pretty pleased that we showed this to. The experts were pleased, we were pleased, and ended up being approved for use for the future. So just to give you an example, here's a final shot of the original knowledge graph. We have one laureate, Ada Younath, who worked in these. We have 2 original keywords, molecules and proteins. This is quite generic, as you can see, quite vague. And we have a ton of other laureates who also worked in these fields, and a few kind of in the middle who worked on both. But under the new knowledge graph, we have Ada Younath, and each laureate is connected to maybe 5 or 6 different, much more specific keywords that I think gives a clear story around people's specialties or subspecialties or even like sub-subspecialties. So that's it. That's my 15 minutes. I can't believe I feel like I stuck the landing. That's incredible. Thank you. If you have any questions, please reach out, email me, andrew.mccornack@eqtpartners.com, or go ahead and access this QR code. We maintain a blog of all the research we do and all of our findings. So that's it. Thank you so much.